Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Second Chance. It's a medium problem of probability type. I'll let you guys pause and go over it once. So essentially, the problem is that we've been given a dice that obviously has the sample space of 1 all the way to 6, where each of these outcomes has a probability of 1 by 6, right? And so we've been given this dice and we get to roll it, and whatever face value comes up, we get paid that particular value. Now, there's a twist in the game that is that if we want to, we can request a second chance and roll the dice again. And but in that case, we have to just accept whatever we have been paid on the second roll instead of the first. So we can't just roll again and then let's say in the first chance I get a 5 and I roll again and then I get a 2. I can't just say that okay, give me the 5. No, in that case I'm gonna have to take the 2, right? If you want your first value, then you have to stop over here. You can't go further, right? So now what we've been asked, since we've been given all of these conditions, right, we have to develop a strategy to play this game. And once we've developed that strategy, we have to calculate the expected value. Now, obviously, we have to develop a strategy where the expected value is maximum, and we have to tell the value of the expected profit for that particular strategy, right? Now, to go about this problem, I would say that try to start with something simple. So try to start with the case where we only roll the dice once and we get paid whatever shows up. Now, this case is pretty simple. Now, first of all, to talk about the expected value of profit, this formula is basically equal to the summation of all the different cases. So basically, we're going to have to let's denote the profit by capital X as a random variable. So for all those cases, we're going to say X is going to take up a particular value of profit. So the probability of that case into the actual profit that we earn. Now this is going to look something like this for the simple case of only rolling the dice once and accepting whatever comes up. So this comes out to be 3.5. Now we have established that the expected profit of rolling the dice once of an independent dice roll is going to be 3.5. So we can expect us to earn 3.5 dollars for a single roll, right? Now let's try to think about the actual problem where we've been given option to roll again if we want to. Now try to think of what's gonna happen, like map it out. So if I get a value of 6 or 5 for that matter, I know that if I were to roll again, my expected profit on my second roll is gonna be 3.5. Now would I choose to do this? Would I choose to roll again? If I already can cash out at 6, well, for 6 it's obvious because that's the maximum possible value. So I might as well just cash out over here. Now if I get a 5 or even a 4, right? I'm gonna think that since I can already cash out at a value of 5 and 4, and my if I choose to roll again, my average value is gonna be 3.5. So it's not worth to take the risk, right? I'm gonna cash out at these values. But this is not the case for values 3, 2, and 1. Since these values are less than this value over here, it's worth taking the risk and trying to roll again. This is the crux of the problem. To take the risk and roll again if we have a value which is less than the expected value of an independent dice roll, which is actually going to be the expected value of the second. This is very important to understand. We do not roll if we get a value greater than 3.5 on our first roll, but we do roll again if we get a value less than 3.5, hoping that since the expected value of a roll independently is 3.5, we're gonna be better off. So to calculate the expected profit for this new strategy, it's going to look something like this. So for all these three cases, which are 6, 5, and 4, it's going to be the exact same. It's going to be 1 by 6 of 6 plus 5 plus 4. But for the other three cases, which is 1, 2, and 3, now I can group them together, which would be 3 by 6, right? So this is the value that we're going to plug in over here. This is the expected profit of our second roll. This is the expected profit of the other cases. This is the probability of getting the other cases, and this is the probability of getting the case where we roll again, right? Try to map this to the formula of E of X is equal to sigma of v of capital X equals to x times x, right? It's important to understand that this x over here is correct, right? Because this x or 3.5 is the profit or the expected profit of the case where we roll again. So calculating this value over here, we get a value of 4.25. And this is the expected profit that we're going to get using this strategy. So this is the answer to the initial question. Now, using this, we can also talk about the case where, let's say, we have been given the liberty to re-roll twice. So in total, we get 3 chances to roll the dice. Now, use the exact same logic. We already know that the expected profit of 2 rolls is 4.25. Now, try to think about what happens for my first roll, very first roll. If I get a 6 or a 5, I know that this is already greater than the expected profit that I'm going to get if I choose to re-roll again and enter the case where I'm basically playing the game that we just talked about. If I re-roll on my first turn, then this basically becomes the game that was initially given in the question, that I've been given 2 chances. I can either cash in over here or I can choose to re-roll again and just get whatever is over here. And we know that the expected profit of this entire game is 4.25, right? So if I have a value greater than 4.25, then it's profitable to just cash in over here. Now, but if I get a value from 4 all the way to 1, in that case, it's smarter to take the risk and say that, okay, I'm going to re-roll again, right? So calculating the expected profit of this entire strategy, it's going to be 1 by 6 or 6 plus 5 plus, now I'm going to group all these cases together and say that this is going to be 4 by 6 of the expected profit that we're going to get in this case of re-rolling, which is going to be 4.25. So I'm going to plug in 4.25 over here, and this comes out to be 4.66 bar. And this is the expected profit of this particular game where we choose where we get to re-roll the dice twice if we want to. So a total of 3 rolls. Now there's also a follow-up question given on the website that what if we're allowed to re-roll the dice as many times as we want? Well, this is a pretty simple answer. It's basically 6 because we keep on rolling until we get the value 6. And we can't get a value more than 6, so we just stop over there. So I hope you guys understood this solution, and thanks for watching.